Hello and welcome back. Let's continue to look at examples of lots and lots of uses for trigonometry. Let's find out all we can about these pairs of triangles. We've got sort of a long, skinny one that's sort of sitting on top of a right triangle down here. And I think the important thing to notice is that we also have one triangle that's sort of this big triangle that overlaps everything. So let's see what we can see about some of these values. Let's start with these angles, theta and beta. So theta, we've got this triangle. Maybe I can highlight that in red. We have this triangle in here, and in this triangle, we can see that we have a right angle triangle, a 50-degree angle, and theta. So when we look at that, well, I know that the angles of a triangle have to add up to 180. So if I take theta plus 50 degrees plus 90 degrees, that should be equal to 180. So again, I can just subtract 90 and subtract 50 from both sides, and I'll get that theta is a 40-degree angle. Nice. Then we have beta up here, and here in this triangle, we can do this in a couple different ways. So let me solve for beta in two different ways. One is that we have three angles in this triangle, and I need to solve for beta, so I would need to know the other two angles. Well, this angle down here, the one opposite the 50-degree angle, this one is supplementary to the 50-degree angle. Why? Because they form a straight line here. So because they form a straight line, these two angles should add up to 180. So if I take 50 plus this angle here, I don't have a name for that one yet, I'll call this alpha, will be equal to 180. So alpha will be equal to 130 degrees. So then now the three angles in here should add up to 180. So 25 plus this 130 plus beta should add up to 180. And if I take 130 away from this side, and then I get 50, if I take another 25 away, beta is in fact also equal to 25. So that's one way to solve for beta. Let's look at another way. So rather than having this be our triangle, one thing that I can do is I can look at this big outside triangle up here. And when I look at this triangle, again, I have three corners. I have 25, the 90-degree angle, and this big angle up here. But this big angle should just be beta plus theta, right? This big angle is just being divided up into beta plus theta. So if I look at this big triangle, I've got a 25-degree angle, a 90-degree angle, and this big one, which is beta plus theta. But I already know what theta is. It was just 40. So all of this should add up to 180. And if I subtract 25 from both sides, if I subtract 90 from both sides, and 40 from both sides, we'll see that beta should be 25 degrees again. Note, we got the same answer both times. So all is good. So we found theta and we found beta. Let's see if we can find some of these other values. So for instance, let's try to work out some of the relationships between these guys. So let me erase some of these red lines in here. So for instance, here we have a triangle. We have a right angled triangle, and we have a 50-degree angle, and we have z and x here. So let's look at the relationship between z and x. Z will be the opposite side to the 50-degree angle. X is the adjacent side to the 50-degree angle. So the tangent of 50 should be equal to z over x. Again, tangent of 50 should be opposite over adjacent. here's the opposite side, here's the adjacent side. Nice. So tangent of 50 is z over x. Another way to relate z and x is to again look at this big triangle that extends all the way around. And with this triangle, I have a 25-degree angle down in this corner. And again, we can look at the tangent being the opposite over the adjacent. And that's going to be relating z and x. But this side length isn't just x. It's 12 plus x. So we'll have to be a little bit careful. So what will end up happening is the tangent of 25 is going to be the opposite side, which is z, over the adjacent side. And this side is going to be 12 plus x. And this is where we get to use some algebra to solve for these guys. Let's multiply both sides of this by x. So we'll get x times tangent of 50 degrees is going to be equal to z. And if I multiply both sides of this by 12 plus x, I get 12 plus x times tangent of 25. And that's equal to z. Oh, both of these are equal to z. I can set them equal to each other, and I can solve for x. So let's do that. So x times tangent 50 is equal to 12 plus x times tangent 25. So again, both of these are just equal to z, and now this boils down to just doing some algebra to solve. I might run out of space here. So let's distribute. So we've got x times tangent 50 is going to be equal to 12 times tangent 25 plus x times tangent 25. Move this to the other side. I've got x times tangent 50 minus x times tangent 25 is equal to 12 tangent 25. I forgot my degrees in here. And then I can pull out an x. So let's pull out an x. So I've got x times tangent 50 minus tangent 25 is going to be equal to 12 tangent 25. And then after all this, I can divide both sides by this number to get that x is going to be 12 tangent 25 divided by tangent 50 minus tangent 25. Oh wow, that's a big fraction. Let's just plug this into Desmos. So let's clear everything, and we will take. We'll have a fraction. So behind my face, there's I can make a fraction. On the top of the fraction, we want 12 times the tangent of 25. Close the parenthesis. On the bottom, we want the tangent of 50 minus the tangent of 25. So I've just plugged in my formula here, and again making sure that everything is in degrees. I hit enter, and we get 7.7. I'll just round to the nearest tenth here. So x we found was 7.7. It was a lot of work, but the algebra shouldn't take too long. It's just maybe a little bit messy. And then there's a few nice relationships which we saw. We had 50, z, and then 7.7, and that gave us just in red. Tangent of 50 degrees is equal to z over x, and we know what x is. X was 7.7. So I can take this times tangent of 50 to get z. And I don't even have to round here. What I can do, one of the powers of Desmos, is I can just take this answer. Oops. I can take this answer, just take that same one, and I can take this times the tangent of 50 degrees. And if I hit enter, I get 9.1925. So if I round that to a tenth, it's going to be 9.2. Oops, I don't want that red. 9.2. And we're slowly starting to fill this in. The next step would be to find y and w, and maybe I won't do these. I've run out of room here, but I have a right angle triangle, so I know that Pythagoras Theorem will apply. So a squared plus b squared should be equal to c squared, as in 7.7 squared plus 9.2 squared should be equal to y squared. And I've got the big triangle lurking in the background here as well. So this side length, which is 12 plus 7.7, all that squared, plus 9.2 squared should be equal to w squared. So we can solve for all these just using Pythagoras Theorem now. Okay, so this was sort of a lot of work, but doable. And now I want to set up this next question as well. So we have a plane is going to fly directly over top our house. So I want to start drawing a little picture. We've got our house, and then we've got our plane, which is flying overhead. So we've got our house, we've got our plane. From 100 feet away from our house. So here we are, and we are 100 feet away. The angle of elevation to the top of the house is 15. So what does an angle of elevation mean? So if you were to look straight forward, that is an angle of elevation of 0. If you look slightly up, so let's say we're looking slightly up, the angle that this makes with looking straight forward is called the angle of elevation. So this angle right here is going to be 15 degrees. And I don't think I want to write that right there. I'm going to draw this slightly better. So the angle of elevation to the top of the house, this is going to be 15 degrees. And then the angle of elevation of the plane is going to be 89 degrees. So this means that if we look up and see the plane, the angle above the horizon, this angle right here, from the base up, is going to be 89 degrees. So then the question is, how far above the house is the plane? So we're looking for this distance here. So we don't know that distance. We have 100 feet, and we know we've got an angle of elevation of 15 and an angle of elevation of 89. So let me draw a more precise picture here. So here's you. Our house is over here, and from the top of the house to us, this forms a 15-degree angle. If we're going straight up from the house, up here we'll have the plane, and this total angle is going to be 89 degrees. And we want to know this length, the distance from the top of the house to the plane, and we know that we are 100 feet away. So this should look surprisingly similar to this guy right here, where we have these two triangles. It's just flipped over a little bit. So we can use the exact same method to solve this, and I will do so in the next video.